So let's start from the Earth origin theory. We have explained the cold origin theory before the internet went off. Then the Earth origin theory is telling us that due to gravitational attraction between the sun and the pre-existing passing stars, there will be a violent collision that will result in some material being turned off to form a planet, in which Earth is one of those planets. So, and the weakness of this theory is the angular momentum cannot be explained. The basis of this collision cannot be explained, and also why the collision is perfectly elastic, it cannot be explained by this Earth origin theory. So we also talk about the peculiar features of the Earth. We said that there is presence of enough water for activities, there is balanced design from the sun, there is presence of rich atmosphere, there is presence of rich atmosphere, we have importance of light on the Earth, so water is regularly available, the force of attraction is also plays a major role, and also the presence of Jupiter that blocks the Earth from much of the incoming debris. All these features make these features are some of the characteristics that make human beings to live reasonably well on the Earth surface. So we also talk about the resources of Earth unit. There are some of the processes like particle acceleration, gravitational pull within the particles, radioactivities in which energy is being involved. Each thermal energy is involved as a result of dissipation of radioactive elements. All these forms are the processes that make the Earth plane, make the Earth to warm up. So we also talk about the ion catastrophe, and we say that this is a process whereby, as a result of the release of thermal energy by radioactive elements within the Earth, raise the temperature of the Earth so that much heat now leads to the melting of iron, melting of nickel and iron. And this now moves to the center of the planet to form the first core. And we said that the process is known as planetary differentiation. And we said that after the ion catastrophe, there are some processes that are formed as a result after the ion catastrophe. And we said that formation of the Earth core, as well as formation of the Earth magnetic field at the outer layer of the formation of the Earth magnetic field, as well as the formation of the Earth core, are some of the events that happened after the ion catastrophe. And we said that we have three major layers of the Earth. We have the crust, the mantle, as well as the core. We said the crust is the most dense part. The mantle is denser, while the core, that is the deep inside the Earth, is the core, which is the densest part. Now let us look at the self-assessment exercise. The first question is asking about if you look at the first question here, the Earth is formed from the remnant particle of what heavenly bodies, according to the Earth origin theory. So if you look at that, if you look at your note very well, you can see that according to the Earth origin theory, the Earth is formed from heavenly bodies of, look at the part of the note where they are talking about the Earth origin theory. They say that it is as a result of the attraction between the sun and the pre-existing stars. So it's formed from the pre-existing stars, which now cause violent collisions. So, and the material that are not formed from the colliding stars now form the planet. So pre-existing stars is the heavenly bodies that form according to the Earth origin theory. And this is telling us that these pre-existing, especially nebulas, are some of the particles that the Earth is formed from the remnant particles of nebulas or pre-existing stars. The second part is talking about the least sources of the heat that cause ion catastrophe. The sources of the heat that cause ion catastrophe are as a result of radioactivity, as a result of gravitational pull within the particles, particle acceleration, that is, the kinetic energy of the particles that come together when they now collide So the particle now turn to heat energy, thereby raise the temperature of the Earth. So these are you just said that the particle acceleration, gravitational pull within the particles, radioactivity are some of the processes that can lead to increase in temperature of the Earth. And also, the question C part is talking about which part of the solid Earth is densest. Not far from this note, you can see that this from this simplified model of the solid Earth, the core is the densest. Why the mantle, why the crust is the densest? That is the outer layer, the middle layer is the mantle, while the inner layer is the core. Later on, we know that this crust is made up of two. We have continental crust and oceanic crust. We have the upper mantle and the lower mantle, and whereas we have the outer core and the inner core. So the part of the solid Earth that is densest is the core. So, and the question here is, why is the ocean located on the surface of the Earth? Ocean is located on the surface of the Earth because there are some water releasing chemical reaction that form, that these now accumulated together to form the ocean on the surface of the Earth. Now, in conclusion, the Earth originated from a pre-existing entities in the universe. These can be particles or part of heavenly bodies. So the internal and external part of the Earth are in regular zone that conform to scientific reasoning. We have the mantle, we have the crust, the mantle, as well as the core. So at the end of this exercise, we have been able to learn that we have two theories that explain the formation of the Earth. These are cold and not origin theory, which I implore you to know the difference between the two. We have mentioned that before. We also said that the characteristics of the Earth, we also mentioned some characteristics of the Earth that make the Earth suitable for human beings to live on. We also explain what ion catastrophe is all about, and some of the processes that lead to ion catastrophe are particle acceleration, gravitational attraction, as well as radioactive process of the aftermath of which is Earth zoning. We also said that the Earth has three basic sections, and these are the crust, the mantle, and the core. Lastly, over 33% of the Earth mass is iron. So on this tutor mark assignment, we have list 5 conditions that make the planet Earth a congenial place for living things to survive. The Earth has among the conditions that the distance, the Earth has the balanced distance from the Earth. The Earth has the balanced distance from the sun. The expenses of light on the Earth's surface. We have the atmosphere that is about 100 miles thick that keeps the surface of the Earth warm. The Earth also has a favorable climatic condition. Water is regularly available, and there is a presence of force of attraction that also enhance a favorable climatic condition on the Earth's surface. So we also, the second part of the question explain the effect if distance of the Earth from the sun were less or more than what is now. The Earth has a balanced distance from the Earth to the sun. So justify the formation of the ocean and atmosphere above the solid Earth. The gaseous part of the Earth, as well as the water releasing the action between the Earth and on the Earth's surface lead to the formation of the ocean, while the gaseous releasing interaction between the Earth and some of the particles within the Earth form the atmosphere. Mention one weakness each of the cold and hot origin theory of the Earth. So, for example, cold origin theory fails to explain the angular momentum as well as the reason for the angular momentum. So this hot origin theory also fails to explain why the angular momentum, the reason for perfectly elastic collision, as well as it also fails to explain why all the planets move in the same direction. Now let's move to the second part of the lectures, and that one is about the 3 layers of the Earth, and that one motion of the Earth. We said that we have 3 basic motion of the Earth: the rotation of the Earth, the revolution motion, as well as the wobble motion. We said that the non-stability of the planet Earth is shown in various events, such as the occurrence of the day and night, seasonal variation, as well as the annual irregular length of days and nights. So we have to, we thought about what revolution is all about, and we said that the revolution is just the movement of the earth around the sun in a fixed path. We said that the revolution caused the formation of the revolution caused the formation of change of climatic season. And we said that the revolution of the earth takes 365 days and 6 hours. And we said that the motion, revolutionary motion, has a periodicity of a year and determine the global season. We also said that the whirlpool motion is a flip-flop motion of the earth, and it's estimated that the northern hemisphere is closer to the sun than the southern hemisphere. So I want to tell you that there are some countries that lie within the northern hemisphere, there are some countries that lie within the southern hemisphere, and there are some countries that lie in between the two. So you have to tell me, and you have to know where Africa, especially Nigeria, is located. Is Nigeria located within the northern hemisphere or the southern hemisphere? You have to note that one. And we say that the rotation is a kind of motion of the earth, motion of the earth about its polar axis. And this rotation of the earth determines the length of the day and night. We also said that the rotation of the earth determines the length of the day and night. It also causes the ellipsoidal oblate shape of the earth. We talk about some of the hypotheses that explain the rotation of the earth. We have the Cassini hypothesis as well as Newtonian hypothesis. So all these are inside your notes, which I will implore you to read about it at least and watch the previous videos recording about this topic. So self-assessment, what will be the length of the day and night when the earth wobbles to the position you go around? You have to explain that. The answer is within, if you read critically your notes, you will find the answer there. So they also ask about the practical experiences on the earth that support Newtonian hypothesis about the rotation of the earth. So we talk about the rotational motion of the earth has an effect on the internal structure of the earth. And we said that there are some geophysical studies that confirm that the crust is inhomogeneous in nature, while mantle is homogeneous in nature. Also, we talk about the formula for calculating the earth flattening. We have said that earth flattening F is equal to RE minus RP divided by RE, where RE is the equatorial radius and RP is the polar radius. So when they ask you to find the earth flattening, you just use the formula F is equal to RE minus RP divided by RE. So, like I said before, there are some factors that are responsible for the sculpture of the earth surface, the shape of the earth surface. And these are some of the causes of the surface shape are gravitational pull, volcanic eruption, interaction between the lithosphere and the two fluid envelope, that is the atmosphere and the atmosphere, as well as the movement of the plates, that is the movement of the lithosphere on asthenosphere. And this is referred to as plate tectonics. That is, plate tectonics is just the significant movement that is noticeable on the earth layer called plates. So under system assessment exercise, the first question they ask you here is that given that the equatorial and polar radar to be 6,378 and 6,356, calculate the flattening of the earth. You just use, since from this equation, your RE is 6,378.388 and your RP is 6,356. Then to determine your F, you just use F is equal to RE minus RP divided by RE, and that one will be 6,378.388 minus 6,356.912 divided by 6,378. And now, if you do it correctly, that one will give you the value for the flattening of the earth. So give a condition for gravitational pull to give rise to a value on the earth's surface. And this is here. If you look at this explanation, they say that after iron catastrophe, side particles experiencing gravitational pull from the interior of the earth. So since the pool is from the all direction, the Earth appears fairly spherical in shape. However, because of the inhomogeneity of the crustal layer that varies in magnitude as a result of the gravitational pull from place to place, depending on the density of the area under study, then that means area with denser crust will appear lower. That it will appear as a lowland area like valley, while area with less dense crust. What I mean is that area with denser crust will appear lower at a lowland than area with less dense crust. So that is the reason why that is the condition that makes some area to appear as a valley than the other area. It depends on the density of the crustal layer on a particular surface. So explain the cause of the oblate spheroidal shape of the Earth. And if you look at this one, also this one is telling you that what causes the oblate spheroidal shape of the Earth is due to the rotation of the Earth. And that one is explained by this passage, and that is as a result of the fact that the centrifugal force decreases towards the pole from the equator. In other words, that will now make us to have a net force toward the center of the Earth, which now increases in magnitude as we move further away from the equator. As a result, the CF, that is the centrifugal force, will decrease to zero at the equator, and we have a mass, but with a maximum centrifugal force. So this one now, consequently, the polar region will now become flattened, while the equatorial region bulges outward. Therefore, the Earth now assumes oblate spheroidal nature. That is, the spheroidal nature is a result of the values of the CF and CP. And we said that the CF will decrease to zero at the equator, but we have a maximum centrifugal force. So as a result of that one, the polar region are flattened, while the equatorial region bulges outward. So that now makes the Earth to assume the oblate spheroidal nature, as you can see from this diagram on page 26. You can see that the equator bulges outward, while the polar one flattening. You can see that RP is the radius of the polar radius, while RE is the radius of the equator. And you can see that the radius of the equator is longer than the radius of the polar, thereby making the Earth shape to form a oblate spheroidal nature. Now let's quickly move to so this one is talking to this tutorial mark assignment is talking about these three types of the Earth motion. I mentioned one effect of each of the motion. You know that one: rotational motion, revolution, and wobble motion. So one causes the formation of day and night. One causes the climatic reason, and the other one can also result in inequality in days, inequality in size of the day or night. And also, we have to sketch a diagram to use to explain cascading hypothesis. This one is also in your note. And how did the Earth assume its fairly spherical shape? We just explained this one now. Now, let's talk about the three layers of the Earth. So the internal structure of the Earth can be probed by using some geophysical methods like electrical method, magnetic method, seismic method, and so on. For example, most of the features that exist on the Earth's surface are the result of the concept of events that took place around the time of formation of the geological time over the years. So this unit will tell us about the models of the interior structure of the Earth based on the scientific facts. So the objective at the end of this class, we'll be telling us about the Earth model based on the chemical formation of the Earth, as well as the ability of the material to flow. So we said that the evidence of the inhomogeneity of the solid earth is as a result of density variation, whereby we said that the surface density of the solid earth has been found to be about 2.65 grams per centimeter cube, whereas the average density of the earth is 5.5 grams per centimeter cube. This is not telling us that deep beneath the earth's surface, there is a denser particles, there's a denser material deep beneath the earth. That is, the density increases with depth. And also the rotation, we can use the rotation analogous of mass, that is the moment of inertia, to also explain that there is change in density with depth. And we say that, for example, we use I is equal to BME square. B, if B is equal to 2 over 5, if B is greater than 2 over 5, that means density decreases with depth. But if B is less than 2 over 5, that means density increases with depth. So, but for the planet Earth, it has already been found that B is equal to 0.330, which is less than 0.4. That means the density increases with depth on the Earth. That means this also supported the fact that density increases with depth. So we can describe the Earth model based on the chemical composition as well as based on the material composition, based on the chemical composition as well as based on the mechanical, that is the ability of the material to flow. We say that based on the chemical composition, seismological evidence gave us the following subdivisions. We have the crust, the mantle, and the core. So these are under the crust, we have the continental crust and the oceanic crust. Each of them has different characteristics, which you can find inside your notes in terms of their thickness, in terms of their physical properties and their material rock mineral, and as well as the rock type that make up each of these components. For example, the continental crust. For example, the continental crust is less dense. It is made up of granite and it has more pores in the rock, thereby leading to decrease in density compared to oceanic crust that is mostly made up of basaltic rock, that is more dense rock and has a smaller pores that accounts for its higher density compared to the continental crust. We also have, in other words, the crust can be divided into 3 layers. We have stable region, we have the semi-mobile region, as well as the mobile bed. So under each of these layers has distinct properties. We say that the oceanic crust are mostly basalt and gabbros, whereby the continental crust are mostly made up of granite. So each of these layers, layer 1, layer 2, and layer 3, has their peculiar characteristics. And we say that the monophysitic boundary, it is the boundary that separates the crust from the mantle, that separates the crustal layer from the upper mantle layer. That is the chemical boundary that separates the specific crustal rock with high pressure content from underlying ultramassive rock. It's just simply the chemical band, it's just simply the band that separates the lower crustal layer from the upper mantle layer. And we said that the second layer we need to know about is the mantle. And this is a solid layer with about 2,100 kilometers thick. It is the largest of all the subdivision. Why? Because 84% by volume and 69% by mass of the Earth is made up of the mantle. And we also said that it's divided into 3. So we have the upper mantle, the transitional layer, as well as the lower mantle. So for the upper mantle, it is made up of 40% olivine, 50% pyroxene, and 10% garnet. And I have to tell you now that at about 100 to 150 kilometers, mantle is hot enough to flow very slowly. That is, upper mantle has the ability to flow very slowly. Although they are solid in mantle is solid in nature, it has a density of about 3.5 to 5.5 grams per centimeter. I mentioned that in the previous class. And that the mantle is also a solid rock. We have the transitional layer, and this is characterized. Transitional layer of the mantle is characterized by an abrupt increase in seismic velocity. It is iron rich. We have the lower mantle where the seismic velocity and density increases steadily with depth. So we also have the Gothenburg boundary, and this is a boundary that differentiates the mantle from the core. And we have the innermost part of the earth that is referred to as core. We have the outer core as well as the inner core. The outer core is about 16% and 30% by volume and mass of the Earth. So we also have to, I have to also remind you that I said the other time that the outer core is liquid in nature, while the inner core, although it is more hotter than the outer core, but it still maintains a solid nature due to the pressure that is so high that the atoms still, although the temperature of the inner core is still higher than that of the outer core, but the pressure is so high that the atom there together still maintain its solid nature. And this earth magnetic field, as well as the earth magnetic field, occur within the outer core, and it's about 2,080 kilometers thick. We also said that, like it is in this part, we said that it is believed that the outer core is in liquid form because seismic earthquake cannot pass through it, and the earth magnetic field, like I mentioned before, originates from the outer core. So we also said that the inner core is 1,050 kilometers thick. It is solid in nature, although it has a higher temperature compared to the outer core, but it's only PV velocity that increases inward within this layer. And this now means that the density increases with depth. So we can describe earth model based on the ability to flow. I said that based on the ability of the earth layer to flow, we have this layer can be identified. We have the lithosphere, which is cold and brittle. That is, the lithosphere is the outermost layer. The lithosphere is the uppermost layer that consists of the crust as well as the solid upper mantle. Lithosphere extends from the surface up to about 100 to 150 kilometers. And we have to know that the lithosphere sits on the asthenosphere. In other words, the asthenosphere and the ionosphere has the ability to flow, and they are made up of the upper mantle layer. So it was reported that toward the center, it becomes hardened again as a result of pressure. Self-assessment exercise 1. So what is the source of the centrifugal force that is responsible for the bulginess of the Earth? You should know that that one is inside your notes in the previous class. How does the density vary from the crust to the core? Crust is the dense, mantle is the denser, and while the core is the densest. Briefly discussing the evidence to confirm that the earth crust is density in homogeneous. So the evidences are the evidence that describe that the crust is density in homogeneous. The evidences are in the first part of the note, and the evidences are as follows. 1, density variation. The inhomogeneity of the earth is showing the following density variation, whereby we said that the surface of the earth, the dense surface density of solid earth is 2.67, whereas the average density of the earth is 5.5. This is telling us that as we increase in depth, the density increases. Also, the rotation analogous of mass, that is the moment of inertia, can also be used to explain the density variation of the crust, depending from one place to another. Then the other one is surface structure of the earth. So we said that the surface of the earth solid witness series of features, such as the formation of ocean and continents, which are consequent of events that took place over a long period of time. And formation of continents, ocean, and atmosphere are some of the structure of the surface structure of the solid earth. We said that continents is as a result of the lava flow, as a result of volcanism from the interior to the outer layer. These lava flow now cooled down and became continents. And we said that the ocean is formed from the interior of the solid earth as a product of the process of heating up and differentiation, whereby some water-bearing elements release their water molecule. They now accumulate on the surface. To form the oceanic water. And we also say that the atmosphere is as a result of differentiation reaction, whereby some gas releasing chemical reaction brought about more gases that accumulated above the solid earth. And this diagram is just telling us the difference between the elevation as well as the ocean surface. You can see that the difference between a point on the continental platform and the ocean surface, that is the sea level, is known as the elevation, usually represented by H. So we have to note that the Earth's surface is constantly being changed by two processes, and this process can be endogenic process or exogenic process. Endogenic processes are processes that occur within of internal origin, resulting in volcanism and tectonism, whereas exogenic processes are processes of external origin, such as erosion as well as deposition process. So all these occurrences lead to formation of, all these processes lead to formation of occurrences such as earthquakes, landslides, tectonic faults, as well as sudden change in thereby resulting in sudden change in landscape. So we also have to note that these occurrences occur as a result of the fact that the Earth interior is also in motion. Though the mantle appears as hard and solid to seismic waves, but it is believed to exhibit a plastic behavior over a large geological time. Also, deeper inside the Earth, we also note that the liquid core probably flows at a geological rapid rate of a few tenths of millimeter per second. So all this process is telling us that the Earth's surface is constantly changed as a result of endogenic process as well as exogenic process. And also the elevation H, as I said before, is the height of the continental platform relative to the sea surface. So average elevation of the continent is around 0.8 kilometers. So this one is telling you about that the Earth's surface can be basically viewed in three forms. We can view from the top surface, or as well as the geoid. The geoid simply is just the geoid is at the sea level, where the sea water will flow to its continent. And simply divine, we can say that the geoid is the physical equipotential surface of gravity. Geoid is the physical equipotential surface of gravity. That is, geoid is the equipotential surface to which direction of gravity is everywhere perpendicular. So therefore, the vertical separation between the geoid and the point on the Earth's surface is known as the elevation. So ellipsoid is the ideal smooth surface of the solid Earth in its oblate form. We said that, and we said that that one is as a result of we have oblate periodial nature of the Earth because of the longer equatorial radius compared to polar radius, which leads to the bulginess of the Earth's surface. So these self-assessments too, what percentage of the Earth's surface is not covered by ocean water? What percentage of the Earth's surface is not covered by ocean water? You have to know the answer to that one. Divine ellipsoid. Ellipsoid is the ideal smooth surface of the Earth in its oblate form as a result of longer equatorial radius compared to polar radius. What other name can you call it? Geoid. What other name? What other name can you call it? Geoid. Geoid is the sea level. Look at it. Ocean surface. How did the ocean form? Ocean is formed as a result of water releasing reaction. Yeah. Look at it. Ocean is formed from the interior of the solid Earth as a product of the process of heating up and differentiation, whereby some water-bearing elements release their water molecules, which now accumulate on the surface to form the oceanic water. So we will continue with our class next week by God's grace. Just for you to read your notes, listen to the voice video recording. So in conclusion, the interior of the Earth composed of crust, mantle, and the core, where the characteristics of each layer varies based on scientific evidences. So most of the surface structure of the Earth are consequences of events that originate from the solid Earth. So in summary, in this unit, we have learned that the two models of the solid are drawn from the chemical formation information, as well as the ability of the material to flow. We have the based on chemical formation, we have the cross demand to the core, and as well as based on the material ability of material to flow, we have the lithosphere, atmosphere, and ionosphere. The earth crust is not homogeneous based on the evidence such as density, relation, as well as analogous moment, analogous to mass moment of inertia. The formation of the continent as measures of its feature of the solid edge. The global distribution of the continent and the others are discussed in this note, as well as we tell the meaning, explain the meaning of the ellipsoid geoid as the elevation, as well as the major sequence of the Earth surface. So this one is explain the three major significant events of the Earth core to the scientific organization of the Earth. Under the outer core, we have the formation of the Earth magnetic field. We have the formation of the Earth magnetic field originates in the outer core. We also said that formation of the Earth magnetic field originates in the outer core. Let me show you where we mentioned that, where we explained that thing. The Earth magnetic field originates from the outer core. The response of the Earth to tidal forces, which affect the axis of rotation and the centrifugal force, also exists in the outer core. And also the reason for bulginess of the Earth at the equator are also associated with the liquid nature of the outer core. That's why I explained that one. I explained the three major significant effects of the outer core to the scientific observation of the Earth. So we continue with our class by Wednesday, where we talk about the relation of some physical property within the solid edge. Thank you.